Hello and welcome to another video in the Reigate Maths series on the second year mechanics content from the Mathematics A-Level. This is a second of two videos focusing on the projectiles topic. My name's Simon, and in this video we're going to be looking at deriving projectile formulae. So what these questions are all about is, instead of doing a projectiles question where we have number, we're going to have letters instead. The thing with these projectile formulae that we're going to derive in this video, we're not necessarily going to do them all, but you do not need to learn them. And in fact, if you do and use them for the questions that we looked at in the previous video, you will not get the marks. Because if you wanted to do that, you would have to show the working we're going to go through today, which takes a long time, and it's just a bit of a faff. So we're going to have a look at this question here. So a particle is projected from a point on the horizontal plane with initial velocity u at an angle of alpha above the horizontal. Given that the acceleration due to gravity is g, find an expression for the time of flight t. And then for part B, find an expression for the range. Okay, now I've drawn a diagram. You might be given a diagram, you might not. If you're not, draw it yourself. The thing with this question is it is practically identical in terms of the core maths that we do to the final example on the previous projectiles video. It's just this time we don't have numbers. So if you cast your mind back to that video, or if you haven't watched it, pause this, go back and watch it, then come back. The time of flight was all about the vertical component. So we used the vertical component to find the time, and then we used that time to find r. So let's have a look at this example now. So we're going to resolve vertically, and we're going to think about our suvat, because it's projectiles, therefore it's a suvat question. So like before, in the vertical plane, what happens to the displacement? Well, the ball goes up, then it comes back down again, and it lands. And it's going to land on exactly the same level as it started. So vertically, it's going to go up and then down. Our vertical component of displacement is 0. Now thinking about the velocity. Again, like in the previous video, we're projecting at an angle, so we know we need to resolve the velocity into its components. And we're only worried about the vertical one for this question, so we have u sine alpha. We don't know the final velocity, but it's unimportant. We know acceleration due to gravity, we're told is g, but that is going down. So because we're taking up as positive, that needs to be minus g. And then we're told the time of flight is capital T. So this is really important because we're using only letters. We've got no numbers in there. We need to make sure that we are using all of the letters that we are told to use. And in fact, if you use lowercase t for this question, you would get it wrong because you are told specifically the time of the flight is capital T. Now we've got all this, it's just a case of using the suvat formulae. Again, we don't have v, so we are going to use the formula s equals ut plus a half at squared. Now we've got that, it's just a case of putting in everything we know. So s is 0, u is u sine alpha, we're timesing it by t, minus a half g t squared. And then exactly like we did before, we're going to factorize. So therefore, a half g t squared minus t times u sine alpha equals 0. We factorize, and we get t is a half g, t times a half g minus u sine alpha equals 0. Therefore, t equals 0, which is what happens at A. So we don't want that one. Or a half g t minus u sine alpha equals 0, which is what's going to happen at b. Now it's just a case of rearranging. So we get a half g times t, the u sine alpha. So t is 2u sine alpha over g. And we're done. This is not a particularly nice thing to write down, but we're done. And that's the thing with these formulae, is they're not nice. Okay, they're going to have u's and alphas, trigonometry, g's still in there, and it's a bit of a pain. But this is kind of the point, because the examiners are very aware that students are very capable of using their calculators. So they put in these more algebraic questions to make sure that you have to know the maths behind the calculator. We're now going to look at part B to find the range. So range is all about the horizontal So the range is s, that's what we're trying to find, and we know the initial velocity is u cos alpha. We know v is the same and a is 0. And now we also know what time is. We've just worked it out. We get 2u sine alpha all over g. Again, it's not very nice, but oh well. Then it's a case of, well, we want to try and avoid using v, so let's use the same formula again. S is ut plus a half at squared. So a is 0, so this bit's going to go, which is lovely, because that wasn't very nice. So we're just going to get r is u, which is u cos alpha times t, which is 2u sine alpha over g. Tidying that up, we get 2u squared sine alpha cos alpha all over g, which is unpleasant. And the point with this is you must simplify. Now, typically with fractions, that's cancelling down, but we can see that nothing is going to cancel. But we need to cast our mind back to the pure side of trigonometry. And look, we've got a 2 times a sine alpha times a cos alpha, which we can then simplify using the double angle formula to sine 2 alpha. So the range, r, is u squared sine 2 alpha over g. And this is what you would be expected to do. If you left it like this, you would lose a mark. Typically for this type of question, the question will be a show that. So it would be show that the range is equal to this. Show that the time is equal to this. That kind of thing. But not necessarily. You need to know that if this type of question comes up, this is what they expect you to do. So this is the last example we're going to look at in projectiles, and it looks very scary. A particle is projected at speed u at an angle of elevation alpha. Acceleration due to gravity is g, so the same information that we were told in the previous example. When the particle is moved a horizontal distance x, its height above the point of projection is y, and we want to show that y equals that mess, x tan alpha minus g x squared over 2u squared times 1 plus tan squared alpha. So first things first, before we even start worrying about this nonsense, let's draw a diagram. So we have our point of projection, and we're going to do something like this. So we know that when it's moved this distance x, the height, this height, is y. When it's moved this distance, x. It's being projected at u at an angle of alpha. So again, the key thing with these, and I know it's very difficult for students to do, it's very easy for me to say, but you've got to trust your algebra. This looks a mess, but you've got to trust that your mess is getting to that. And it will do, I promise. So let's approach this like we were doing before. Let's think about our suvat in two directions. So let's do vertical and horizontal. Okay, we know the vertical distance, or the vertical displacement, is y. And like before, we know that the vertical velocity is u sine alpha. We don't know v, we know that a is minus g, and we know that there is some time. We don't know what the time is, but we know it's the same time horizontally and vertically. And that's the key thing with this question. So we know the horizontal distance is x, the horizontal component of velocity is u cos alpha, and then we know the rest of the information here. This is now all that we need in order to answer this question. Let's look at what we're trying to do. We're trying to get y equals some stuff. Looking at the equation we're going to use, it's the same equation as before, that s equals ut plus a half at squared. But if we think about it, what is that equation going to have a bunch in? It's going to have a lot of t's. We don't want t's in our answer, we want x's. So if we can come up with some equation here for t, we can then substitute that into what we end up with here. So normally we'll do starting here, then do this one. Because we know the distances or the displacements, we're going to start here and get to here. So we're going to resolve horizontally, and we're going to use our tried and tested s equals ut plus a half at squared. Why do we do that? Because a is 0. Okay, so we know that s is x. That's going to be u, so u cos alpha times t. So we're going to write t in terms of everything else. Now this doesn't look very pleasant, but this is where the trusting your algebra comes in. Because if we look at what we're trying to get to, we've got u on the denominator of a fraction. We have x in the numerator of a fraction, and we've got some horrible thing with trig. Well, that doesn't look a lot like this, but it does, because we know trig identities. One plus tan squared is sec squared, which we know is 1 over cos squared, and we've got cos on the denominator. Look, they're all squared. Our formula has a t squared in it. It's also got a t, which is going to tidy things up here. So this is what I'm saying about this type of question. If you trust your algebra and trust in what you're doing, it will come good. So now we're going to resolve vertically. We're going to use the same equation. So we know that y is going to be u sine alpha times t, which we've just worked out. X over u cos alpha plus a half times a times t squared. We're very nearly there. All we need to do is simplify and tidy up. So we get u x sine alpha over u cos alpha minus g x squared over 2u squared cos squared alpha. Again, this still looks like a mess, but Again, if we look back to what we're trying to get to, we're nearly there. We just need to make sure we write all the bits down. Here we can see the u's are going to cancel. And sine over cos is tan. So that sorts out that first term. Because of the way the answer looks, I'm going to write it with this fraction separate from the 1 over cos squared. As we've said, we know that 1 over cos squared is sec squared. And likewise, we know that sec squared is 1 plus tan squared. As required. The process for this question is pretty much exactly the same as the process of the questions we were doing in the previous video with numbers in. It's just harder because it's got letters, but it's still exactly the same method. You still have to multiply things out, look at what you're doing, and use Suvat formulae. In this case, we use the same one twice, and that's really common with this type of projectiles question. What they could then do with this is tell you particular values for x, y, and u, for instance, and ask you to find alpha, or they might give you particular values for y, alpha, and u, and get you to find x, that kind of thing. So they might get you as a part B to use your formula. But again, even if you can't do part A, this will be a show that, so you can still use the answer here. So they're not the worst people in the world, examiners. They do try and give fair questions. But again, the key thing with this question is trusting your algebra. Trusting that you know what you're doing. Even if it feels uncomfortable, even if it doesn't feel right. Like this might not necessarily feel right because it looks like a mess. But trust in what you're doing and trust that things are going to simplify. Because if you can look at this line and go, well, I've done that, I cannot see that I've done anything wrong, then you're clearly going the right direction. If you haven't done anything wrong, you're probably going in the right way. And it's just crunching through and trusting that you're going to get there. Which, if you practice, becomes much easier. Thank you for watching.